Hello there, my fabulous chemistry students. Video number 5, writing and naming specifically ionic compounds. We're going to use the international rules to figure out how to write and name these things. So, what's so special about writing and naming an ionic compound, you say? Well, first of all, they are one of the two most common compounds we will come across. And basically, we need a universal rule so all of us chemists know when I see a name, what it is. So basically, the game is this. Can I go from name to symbol and then from symbol to name correctly? And so we'll have to have a set of rules that we can follow so we can do that, okay? So first of all, we want to make sure that these rules are what we call universal because these compounds should be called the same thing in, not just the United States and Canada, but, South America, Europe, England, France, they're going to have the same actual chemical name, okay? Because chemistry is very universal. Um, IUPAC is that acronym. It stands for International Union of Pure Applied Chemistry. You'll never hear me say that big one again. I'll only say IUPAC, and that's about it. So, first off, all compounds have what we call a common name and a chemical name. Salt's a good one. We call table salt on our French fries, salt, but its actual chemical name is sodium chloride. Okay, so it has a chemical name and it also has a common name. We call it salt. It is a particular kind of salt. Salt's actually a generic term, much how like Kleenex has become a generic term. But the other thing that these notes fail to tell us is that there's actually also what we call industrial names for certain chemicals that they're going to buy and sell on the open markets. And certain industries give certain chemicals their own name and their own spin on names. So there's some of these chemicals that actually have 7 names. We're only going to deal with, for sure, the IUPAC name, and that'll keep things clear for us, okay? So when I do any ionic compound, very first and foremost, I'm going to name the positive element first, which just so happens to be the metal. Okay, we're going to name the metal first. We're going to leave that name just as it says, zinc, iron, sodium. Then we're going to name the second element the negative element or the non-metal, because remember, a ionic compound is always a metal and a non-metal. And I always say it that way first, too. I never say, hey, it's a non-metal and a metal. I always say it's a metal and a non-metal. And that's my hint into the how I name it. Because if I say it metal, non-metal all the time, that's just how I name it, too. I name the metal and then the non-metal. The only thing that's different is that on the non-metal, for example, fluorine, I'm going to change it to end with "ide," like fluoride or chloride. So that's pretty much the rules for naming an ionic compound. We're going to try a few real quick. So I see Na, well, that's sodium. And then I'm going to change chlorine to chloride. And yes, I'm pretty short. So I'm going to go down to this one down here. Li is lithium. Keep the metal name the same, lithium. And then iodine is going to go to iodide. Okay. I see aluminum sulfide, calcium bromide, potassium oxide. Okay. So now I need to go backwards. So here we go from chemical name or symbol, or yeah, the chemical name to the symbol. Let me change color so we're doing things differently. And I'm going to bring in to play something right now at the risk of making the video too long, something that's going to become very important. And it was a trick. Remember in the last video I was talking about how, well, I could take the formal charge of Na was 1, and I had one of those. I can multiply it down, and my total plot was a positive charge. So now I need a total -1 charge to equal 0, and I could come back up and divide by the subscript of chlorine, which was 1, and say, okay, so this has got to be a -1, not a positive one. That's a -1. Well, there's a trick that'll actually get us through this a lot faster, and I'm going to show you right now the trick, okay? Lithium bromide. So it's lithium and bromine. What I'm going to do is I'm going to look in my handy dandy reference table. Lithium is a +1, but what is bromine? And bromine is a -1. So this is going to work. I'm going to have a +1 here and a -1 here. And the trick here is what we call the crisscross. We'll do this again later, but I want to make sure we write these right. So I bring the numbers down and not the charges. And I got LI, BR. They would both be ones for their charges. That's a +1 and a -1. And when we don't have any multiples, when we only have single atoms, we just go ahead and write LiBr. Okay, let's see. Sodium and fluorine, magnesium and chlorine. There's a good one. So let's do magnesium chloride just so you can get a hint of why this is important. You can see up here, now I have the 2 and the 3, and here I have a 2, and here I have a 2 and a 1. So we got to make sure we can do that. So magnesium chloride, that's magnesium and chlorine. I look up magnesium's charge is a +2, chlorine's charge is a -1. Well, how many -1s do I need to match with the +2? Well, I need 2, and the easiest way to figure that out is to crisscross. Okay, we'll bring those numbers down, not the signs, just the numbers. So that's going to be Mg with a 1, so I'll leave it blank, Cl with a 2. MgCl2 is magnesium chloride. Potassium iodide is just a 1-to-1, so I'm not going to do that. I'll leave that one to you. But I wanted to touch base on this crisscross method so that when we go from the chemical name to the formula, we actually get the formula right. And when we start balancing equations next unit, things are going to be very, very dependent on that being done right. You'll see what I mean, because I'm going to keep track of how many of each atom I have. Polyatomic ions, many atoms put together to form an ion. What we do is we just use the name straight out of the reference table. So we see sodium, so that's just sodium. And if I go to table E, I'm going to see that OH is something called hydroxide. So we don't change the name. We just call it what it is. Okay? And then on table E, when we look at the next polyatomic ion, I see NO3. So let me go to this handy dandy reference table one last time. Well, I don't even know why I closed it. Actually, I just have hydroxide memorized. All right, so NO3 is nitrate, which is what I figured it was. I got K is potassium. Nitrate. And this is where, when I see a word like this that ends in an 8 or an ite, I'm not really sure what it was. When in doubt, check E out. So now I can go backwards. Hydroxide is the OH, so ammonium hydroxide. Ooh, ammonium is NH3. So it's NH3OH. I believe they both have -1 charges, so they crisscross. Calcium phosphate. Phosphate is PO4. It's got a -3 charge. Calcium is Ca, and calcium has a +2 charge. So I'm going to crisscross down my charges and say I need Ca3PO4. I need 2 PO4s. So I'll put that whole thing right in parentheses. Okay, that's crisscrossing to build our molecules perfectly based on their name, okay, and their charges. Transition metals tend to have more than one oxidation number, so that's where we start to use the Roman numerals. They're going to come after the metal and we'll put it in parentheses, and they call it the stock system. So that came up in our Quizlet, I do remember. So here we go. I got cobalt chloride could have a formula of COCl2 or COCl3 when I crisscross the charges, right? Because I don't know, is CO a +2 or a +3? Well, I really don't know. So here I'm going to have to crisscross backwards. I'm going to have to take the 2, bring it up, the 1, bring it up, and that goes to CO with a +2 charge, Cl with a -1 charge, and now I'm going to put a Roman numeral 2 after cobalt. So it's going to be cobalt, Roman numeral 2, chloride. This way, I know it's not CO with a +3 charge because the Roman numeral is the charge. That's the same. The Roman numeral is the charge. Here, I'm going to undo my crisscross, bring the 1 up, bring the 3 up. That gives me CO with a +3, Cl with a -1. Here I have a different charge. So that's going to be cobalt 3 chloride. Now, let's just take these crisscrosses off so we can see the actual elements again. And COCl2 and COCl3 are very different things. And if I look, the only difference in the name is the Roman numeral because they're cobalt and chlorine. I just need to know how much of each. Okay, so we have some more to write. I want you to practice these. Okay, and now we can use our formal charges, our crisscross method, to go backwards and forwards from naming our ionic compounds. Sorry the video ran so long, guys. The rest of them are going to be a little shorter, I do hope.